Hello everyone, I'll be talking about measures of variation. In the previous videos, I mentioned about measures of central tendency and skew distributions, video number one and video number two specifically. And I made mention also of the frequency distribution table video. So now we're going to look up into measures of variation. And if you look at the measures of central tendency and measures of variation in statistics, they are actually coupled. So we look at the central location of the data by following mean, median, mode in the measures of central tendency and looking into the heterogeneity or homogeneity of the data on whether how close the data are or how far the data are from the central location is the focus of the measures of variation. So these are the objectives of this video. How to find the range of a data set, how to find the variance and standard deviation of a population and sample. Remember that in the previous videos, video number one and video number two, on measures of central tendency, I emphasize about population and sample. How to use the empirical rule and Chebyshev's theorem to interpret standard deviation, how to approximate the sample standard deviation for group data, how to use the coefficient of variation to compare variation in different data sets. So looking at the range is actually taken in the determination of frequency distribution table. Remember the video about frequency distribution table, one of the terms there is actually on range. So range is actually the difference between the maximum value and the minimum value. Or in this case, we have maximum data entry minus minimum data entry. Finding the range, two corporations each hired 10 graduates. The starting salaries for each graduate are shown. Find the range of the starting salaries for Corporation A. So starting salaries for Corporation A in thousands of dollars. So salary 41, 38, 39, so forth and so on, up to 42. And then starting salaries for Corporation B in thousands of dollars. So salary 40, 23, 41, 50, 49, 32, 41, up to 50. So the solution in finding the range, we can actually arrange the data from lowest up to the highest one. So we have 37, 38, 39, 41, 41, 41, 42, 42, 45, then 47. So we look at the minimum value and we look at the maximum value. So range is equal to the maximum is 47, the minimum is 37. So range is equal to 10. So the range of starting salaries for Corporation A is 10 or $10,000. Variation. Both data sets in the last example have a mean of 41.5 or 41,500. A median of 41 or 41,000 and a mode of 41 or 41,000. Remember that the data are actually in terms of $1,000. This given in here in thousands of dollars. So the difference in that is that the entries in the second set have greater variation, as you can see in the figures on the next slide. The starting salaries for Corporation B are more spread out than those for Corporation A. So we look at here. No? So we look at Corporation A and Corporation B. So we have the starting salary in thousands of dollars for both corporations. So in here, that is the starting salary, and in here is the starting salary. So we look at into the different perspectives now of looking at the mean, median, and then mode. So deviation, variance, and standard deviation. So standard deviation, the difference between the data entry X and the mean of data set. So population data set. So we have deviation. We have x is equal to x minus mu, wherein mu is the population mean. Remember, in the measures of central tendency, I mentioned about mu, population mean, and I mentioned about x bar, or the sample mean. So sample data set, deviation of x is equal to x minus x bar. So again, mu, population mean, x bar, sample mean. So we have the population variance, sigma to the second. So summation of quantity x minus mu to the second divided by capital letter N. And the population standard deviation is sigma is equal to the square root of sigma to the second, or the square root of summation of quantity x minus mu to the second divided by capital letter N. So this one, sigma to the second, is the population variance, and the sigma is the population standard deviation. So if you square sigma, you will get sigma to the second, and that's the population variance. If you're going to get the square root of sigma to the second, you will get sigma, and that's the population standard deviation. Remember about taking square root and the process of the non-taking of square roots. So, then we look up into deviation, variance, and standard deviation. Okay. So
Alert from
look
System
up
UI
into
server.
this case, no?
Low battery.
Observations about the standard
Alert
deviation.
from
I'll give you
low
5
battery.
minutes to go over this. About observations about the standard deviation. Okay, so I assume that you have read observations about standard deviation from bullet number 1, bullet number 2, and then bullet number 3. So take note of that. So we look at the finding population variance and standard deviation. So find the mean of the population data set. So mu is equal to summation of x divided by capital letter A. Then find deviation of each entry. So we have x minus mu. Then third, square each deviation. So quantity x minus mu to the second. Then add to get the sum of the squares, that is SS sub x, is equal to summation of x minus mu raised to the second. Then we look up into number 5, divide by capital letter N to get the population variance. So that is sigma to the second is equal to summation of quantity x minus mu to the second divided by capital letter N. Then find the square root to get the population standard deviation. Sigma is equal to the square root of summation of x minus mu raised to the second divided by capital letter N. Example, finding population variance and standard deviation. So find the population variance and standard deviation of the starting salaries for Corporation A listed in the first example. So for this data set, capital letter N is equal to 10, summation of x is equal to 415. So look at the data set, look at the data in Corporation A, review the video. So we have here Corporation A, these are the data being provided in here. We have Corporation A from 41, 38, 39 up to 42. This is the data that we are actually calculating in terms of the standard deviation. So mu is equal to 415 divided by 10, so 41. And then finding population standard deviation. So determine the deviation for each data entry. So deviation is x minus mu. So that's 41 minus 41.5, 38 minus 41.5, 39 minus 41.5 up to 42 minus 41.5, 0.5. You get the total of the first column, and this total is what we call summation of x. That's 415. And the total of the second column for x minus mu column. And that is what we call summation of x minus mu raised to the second, and that is equal to 0. Next, determine SS sub x. So still we have the salary column, the deviation column. So the first two columns are copied from these two columns. Then we have the squares. So quantity summation of x minus mu to the second. So meaning the entry in the second column is raised to the second or multiplied to itself. It is negative 0.5 to the second or negative 0.5 times negative 0.5. So 0.25. Negative 3.5 to the second or negative 3.5 times negative 3.5. So 12.25. Then so forth and so on up to 0.5 raised to the second or 0.5 times 0.5. So that gives you 0.25. So you're going to get the sum of the second column, which we call summation of quantity x minus mu equals 0. And the SS sub x, that's the total of the last column. That is the sum of all the values of quantity x minus mu to the second. And that's 88.5. So while watching, you can actually get your calculator and then verify the values found in the table that we are looking at now. So finding population standard deviation. So population variance. So sigma to the second is equal to summation of quantity x minus mu to the second divided by capital N. So we have 88.5 divided by 10. And since the quotient is not exact, you're going to use approximation. So approximately 8.9. So to get the population standard deviation, you're going to get the square root of the population variance. So sigma is equal to sigma to the second, and that is equal to the square root of 88.5 divided by 10. So it's actually the population variance is equal to this one, sigma to the second, or 88.5 divided by 10, or approximately 8.9. So the square root of the population variance is equal to the population standard deviation. So we have square root of 88.5 divided by 10, and that is approximately 3.0. So the population variance is about 8.9, and the population standard deviation is about 3.0 or 3,000 US dollars. So deviation variance and standard deviation still in terms of sample variance. So we have S to the second is equal to summation of quantity x minus x bar to the second divided by n minus 1. That small n refers to sample and minus 1 is constant. So we have simple standard deviation. So we have not sample, as simple as sample. It's the wrong spelling here. Sample standard deviation is actually the square root of the sample variance. So S is equal to the square root of S to the second. And that is equal to the square root of the summation of quantity x minus x bar to the second divided by small letter n. So in general, we have the population variance. If you are given the population variance, you get the square root of the population variance that will give you the population standard deviation. If you are given the sample variance, that is S to the second, then the square root of the sample variance is equal to the population, the sample standard deviation. So square root of S to the second is S, that is sample standard deviation. And that S to the second is what we call sample variance. So we have 4 different symbols for now. Sigma to the second, population variance. Sigma, population standard deviation. S to the second, sample variance. And S is the sample standard deviation. So finding the sample variance. So in words, we have Find the mean of the sample data set. Symbol, we have x bar is equal to summation of x divided by small letter a. Find deviation of each entry, that is x minus x bar. Square each deviation, so quantity x minus x bar to the second. Add to get the sum of the squares, that is SS sub x. That is equal to summation of quantity x minus x bar to the second. That is actually the sum of all the values of x minus x bar to the second. Then number 5, divide by n minus 1. So small letter n, the total number of sample size, and that minus 1 is constant to get the sample variance. So s to the second is equal to summation of quantity x minus x bar raised to the second divided by n minus 1. So find the square root to get the sample standard deviation. So s is equal to the square root of summation of quantity x minus x bar to the second divided by n minus 1. So finding sample variance and standard deviation. So in a study of high school football players that suffered concussions, researchers placed the players in two groups. Players that recovered from their concussions in 14 days or less were placed in group 1. Those that took more than 14 days were placed in group 2. The recovery times in days for group 1 are listed below. Find the sample variance and standard deviation of the recovery times. So 4, 7, 6, 7, 9, 5, 8, 10, 9, 8, 7, 10. So the solution, so we have the table type in terms of x, the deviation, and the squares of the different values of the second column. So we have find summation of x, find the standard deviation for each data entry is, then find the sum of the squares. So look at this table. So from 4, 7, 6, so forth and so on, up to 10, the total is summation of x, which is equal to 90. And then deviation, we have x minus x bar. That is actually negative 3.5, negative 0.5, up to 2.5. Remember that x minus x bar, calculate first the value of the mean, and then deduct that value of the mean from x. Then next, we have the square, so x minus x bar to the second. So we have now negative 3.5 times negative 3.5, or negative 3.5 raised to the second. That will give you 12.25. So negative 0.5 raised to the second, or negative 0.5 times negative 0.5. So that gives you 0.25. So up to 2.5, and that 2.5 raised to the second, or 2.5 times 2.5. So that gives you 6.25. And get the total, that is SS sub x, or we call that one as the total of the third column. And the total is 39. So you can get your calculator and then verify on the values of the table that you're actually looking at into my screen. So we have x, x minus bar column, and then the quantity x minus x bar to the second. Remember how to get these values in the second. Calculate first x bar, then deduct x bar from the value of x. So for this data set, we have n is equal to 12, summation of x equals 90. So we have the mean is x bar 90 divided by 12, so 7.5. So we have here 7. So we have 4 minus 7.5, so negative 3.5. Where did I get 7.5 from this? 90 divided by 12. So 7 minus 7.5, negative 0.5. Then up to 10 minus 7.5, that will give you 2.5. Then plug in the values to the formula s to the second is equal to summation of quantity x minus x bar divided by n minus 1. So we have now 39, then divided by 11. We didn't get 11, n is 12 minus 1, so we have 11. So 39 divided by 11. Then we use approximation because the division is not exact. So 3.9. How to get the sample standard deviation? So you get the square root of the sample variance. Remember I mentioned that the square root of the sample variance is equal to the standard deviation. So square root of 39 divided by 11, so that is approximately 1.9. So remember, the the value is not exact, so we use approximation symbol. So the sample variance is about 3.5 and the sample standard deviation is about 1.9. Remember that if it is approximation, we use the term is about. No? So we have is about. But if the value is exact, you're going to say is. If, for example, the sample variance is equal to, the value is exact, 7, then you're going to say the sample variance is 7 because that is exact. So using technology to find the standard deviation. So for now, we have the use of technology in calculating mean, median, mode, or the measures of central tendency, and the use of technology for the calculation of the standard deviation. So for our class, I'll be introducing Microsoft Excel in the next video on how are we going to calculate those different values using technology. But of course, you're going to do it manually first so that we will be able to have that appreciation of the technology once you are able to do the computation. So in here, we have sample of these rental rates, dollars per square foot per year for Los Angeles, as shown in the table. Use technology to find the mean rental rate and the sample standard deviation. So these are the given data. So if you're going to use technology, Minitab for example, then this is the output. No, automatic the values are actually being provided. What you are going to do is you have the software and you are going to encode the data, then do some clicks in the software. Then you will be provided with the mean, then the standard deviation, the minimum value, the value of the median, the value of the maximum entry. That's for the use of Minitab. Using Microsoft Excel is what we're going to use next time. So we have Excel. We are provided with this different data from row number 1 up to row number 38. That's what we are going to look at next time, how to use the Microsoft Excel. And then we look at into the PI84, another technology. So we have here automatic, there is what we call calculation of those different values directly. So take note, we have PI84, we have the Excel, the Minitab, and we have also SPSS, no? The statistical package for the social sciences. So I repeat, the SPSS, or the statistical package for the social sciences. So those are the things that we use in the technology. But in our class, we have to make use only of Microsoft Excel, the basic ones. So interpreting standard deviation. So standard deviation is a measure of the typical amount an entry deviates from the mean. The more the entries are spread out, the greater is the standard deviation. So if you look at this data entry only one, so X bar is equal to 5, and there is no standard deviation. The standard deviation is 0. If you look at this data entry, X bar is equal to 5, the standard deviation is 1.2. And then we have here data entry, X bar is still 5, and then the standard deviation is 3.0. So if you look at the data, as the value of the standard deviation increases, you would notice also that the values are getting far, or the graph is actually spreading out. But the closer the value of the standard deviation to 0, you would notice that there is what we call closeness of the data or closeness of the graph, as shown in the example on my screen. Take note also that although the mean is the same, X bar is equal to 5, X bar is equal to 5, X bar is equal to 5, but the standard deviations are different. So having different means would have a possibility of having different standard deviations. So take note of this example. Estimating standard deviation. So we have here capital N is equal to 8, mu is equal to 4, capital N is equal to 8, mu is equal to 4, capital N is equal to 8, mu is equal to 4. So we look up into these different data sets wherein the means are the same, and then the population data are also the same. No? Capital N is referring to the total number of members in the population. So take note on the difference of small letter n and capital letter N, which I repeatedly mentioned on what is N in capital letter and what is N in small letter. So again, capital letter N is population and small letter n is referring to sample. So estimating standard deviation. So in here we have capital N is equal to 8, mu is equal to 4. So each of the 8 entries is 4. So the deviation of each entry is equal to 0. So sigma is equal to 0. Remember that the height is equal to 8. So the frequency is 8. That means there are 8 fours in the data set. Looking at this example, so we have this graph, the frequency 4, 4, 3, and then the frequency for 5, 4 also. That means there are 4 threes and there are 4 5s in the data set. So each of the 8 entries has a deviation of plus or minus 1. So the population standard deviation should be 1. By calculating, you can see that sigma is equal to 1 also. And then number 3, each of the 8 entries has a deviation of plus or minus 3. So the population standard deviation would be about 2. By calculating, you can see that is greater than 2 with sigma approximately 2.2. So you can make use of the formula in calculating the standard deviation. So in this case, when we interpret, we have 1, the frequency is 2. For 3, the frequency is 2 also. 5, the frequency is 2. 7, the frequency is 2. That means there are 2 1s, there are 2 3s, there are 2 5s, and there are 2 7s. So that is the component of the entire data set. And this sigma approximately 2.2, you can make use of the formula. So verify. So interpreting standard deviation, the empirical rule, 68-95-99.5 rule. So for data that is symmetric or bell-shaped distribution, remember the videos on measures of central tendency 1 and 2, I mentioned about symmetric distribution. And sometimes we call it as normal distribution, and sometimes we call that one as bell-shaped distribution. So about 68% of the data lie within one standard deviation of the mean. About 95% of the data lie within 2 standard deviations of the mean. And about 99.7% of the data lie within 3 standard deviations of the mean. So interpreting the standard deviation, empirical rule, 68-95-99.7. So remember, this one is what we call the normal curve. This is the standard normal curve or the normal distribution. And we call this as the bell shape or the normal distribution or the symmetric distribution. So the total areas found in the graph is 100. And we have some divisions according to the empirical rule. This 34%, 34%, so total is 68%, for one standard deviation. And then we have 13.5%, and a total of 95%. So where do we get this 95%? 13.5 plus 34 plus 34 plus 13.5. So total is 95%. And then we have, this one is 2.35, this one is 2.35% also. So We have 99.7% within three standard deviations. So how do we get 99.7? So 2.35% plus 13.5 plus 34 plus 34 plus 13.5 plus 2.35 will give you approximately 99.7%. And why we say within three standard deviations? Because each distance is equal to one standard deviation. So this one standard deviation, this one another standard deviation, this one another standard deviation. So if we count, starting from X bar, we have three standard deviations going to the right. We have 1, 2, 3. So the first one is 34%, the other one is 13.5, the other one is 2.35%. So three standard deviations going to the right. Then three standard deviations also going to the left side. So we have 1, 2, and then 3. And this is composed of 34%, 13.5%, then 2.35%. So total, 6 standard deviations, 3 going to the right and 3 going to the left side. So remember, 68% within one standard deviation, 95% within two standard deviations, 99.7% within three standard deviations. So using the empirical rule, we have some problems about using the empirical rule. In a survey conducted by the National Center for Health Statistics, the sample mean height of women in the United States was 64.2 inches, with a sample standard deviation of 2.9. Estimate the percent of the women whose heights are between 58.4 inches and 64.2 inches. So we have here the distribution of women's heights is shown. Because the distribution is bell-shaped, symmetric, or normal, you can use the empirical rule. So the mean height is 64.2. So we have height of women in the US aging 20 to 29. So we have here 34.13%, 13.59%, and we have here x bar minus 3s, x bar minus s, x bar plus 3s, x bar plus 2s, x bar plus 3s. So we have there was 64.2 within a sample standard deviation of 2.9. So the solution, when you subtract two standard deviations from the mean height, you get x bar minus 2s. That is 64.2 minus 2 times 2.9. So we have 58.4. Because 58.4 is two standard deviations below the mean height, the percent of the heights between 58.4 and 64.2 inches is about 13.59% plus 34.13%. That is equal to 47.72%. So about 47.72% of women are between 58.4 and 62.2 inches tall. So I repeat now. So we look at into this distribution and we look at the 64.2. Now, where do we get 64.2? It's given that the mean is 64.2. And how do we get 67.1? So 67.1. We know that the standard deviation is 2.9. So we have 64.2 plus the standard deviation 2.9 will give you 67.2. So check 64.2 plus 2.9. So 2.9. So that will give you 67.1. How to get 70? 67.1 plus 2.9, the standard deviation, 70. How to get 72.9? So 70 plus 2.9, 72, 2.9. So how to get it? Start with the mean, then add the standard deviation. Then if you have the second now, going to the right, so we have to add the standard deviation 2.9. Then to get the third, You get the value 70.0 plus 2.9, the standard deviation. So you will get 72.9. Then going to the left, so 64.2 minus 2.9, the standard deviation, so 61.3. 61.3 minus 2.9, so 58.4. Where do we get the 2.9? The given standard deviation. And then we have 61.3 minus 2.9, 58.4. Then 58.4 minus 2.9 will give you 55.5. So going to the left, it's actually the mean minus the standard deviation. So again, 64.2 minus 2.9, 61.3. 61.3 minus 2.9, so 58.4. And then 58.4 minus 2.9, 55.5. So we have now this curve with the mean 64.2 and a standard deviation of 2.9. Three standard deviations going to the right and three standard deviations going to the left side. And again, when you subtract two standard deviations from the mean height, you get, so x bar minus 2 is 64.2 minus 2 times 2.9, so 58.4. So we have 58.4. Because 58.4 is two standard deviations below the mean. The percent of the heights between 58.4 and 64.2 inches is about 13.59 plus 34.13%. So we have 47.72. So we have 13.59, the location, this one 34.13%. So about 47.72% of women are between 58.4 and 64.2 inches. Then we have the Chebyshev's theorem. The portion of any data set lying within K standard deviations, now K greater than 1, of the mean is at least 1 minus 1 over K to the second, where K is equal to 2. In any data set, at least 1 minus 1 over 2 to the second, or 3 divided by 4. You know how to operate this one using your basic math. Or this one is equal to 74%. So look at your basic math. 1 minus 1 over 2 to the second. 2 to the second is 4. That is 1 minus 1/4. So that will give you 3/4. Then K is equal to 3 in any data set, at least 1 minus 1 over 3 to the second, or 8 over 9, or about 88.9% of the data lie within 3 standard deviations of the mean. So take note, recall your basic math, the operations of fractions. So using Chebyshev's theorem, the age distribution for Georgia and Iowa are shown in the histographs. Apply Chebyshev's theorem to the data for Georgia using K is equal to 2. What can you conclude? Is an age of 100 unusual for Georgia? President, explain. So look at the graph. Mu is equal to 37.3. Sigma is 22.3. In Iowa, mu is 39.2. Sigma is 23.5. Then we have the computation. K is equal to 2. So mu minus 2 sigma is equal to 37.3 minus 2 times 22.3 is equal to 7.3. Then mu plus 2 sigma, approximately 37.3, plus 2 times 22.3 is equal to 81.9. So you can say that at least 75% of the population of Georgia is between 0 and 81.9 years old. Also, an age of 100 lies more than 2 standard deviations from the mean. So this age is unusual. Standard deviation for group data. So this one for group data, we're not going to take up this one, but this one is really existing, but we don't take up this one. Of course, you know how to calculate the frequency distribution table. So given the frequency distribution table, you can actually have this, but we will not take up this one in detail. And just show this one so you will know there exists a computation for group data. So we have this one, finding the standard deviation for group data using midpoints of classes. Using midpoints of classes, the solution using midpoints of classes is being presented. The detailed solution using midpoints of classes is there. The solution of classes, so that's the final value. So I am just showing you the computation of the standard deviation for group data, finding the standard deviation for group data. Well, I'll just flash this one for additional knowledge, but we don't need to take up this one in class. This one is an upper class statistics. Then we have this one, the computation. Then we have this one also, finding the standard deviation. Then using the midpoints, then the solution, and then the other solution part, then another solution, then the final answer. So an estimate for the sample mean is 192 per year, and an estimate for the sample standard deviation is 160.30 per year. And now we're going to have the coefficient of variation. This one is very important now for statistics class and the assessment of learning class, coefficient of variation. So describes the standard deviation of data set as percent of the mean. It's actually a percent of the mean. So for population data set, so we have CB is equal to sigma divided by mu times 100%. Then the sample data set CB is equal to small s divided by x bar. That is 100%. So take note of the formula, population data set and the sample data set. So comparing variation in different data sets. The table shows the population heights in inches and weights in pounds of the members of a basketball team. Find the coefficient of variation for the heights and the weights, then compare the results. So heights, 72, 74, up to 73. The weights, 180, 168, up to 210. So we have the solution. So the mean height is mu, approximately 72.8 inches. So the standard deviation sigma is approximately 3.3. So that will be your assignment. Calculate mu and calculate sigma using the formula. So these are the data given. So I would like you to calculate in terms of the height, calculate the population mean and the population standard deviation. That is assignment number 1. To be submitted for every O2 Monday, on Monday also next week. For all in the 303 research class, you're going to have that one on Tuesday of next week. Submit that one on Tuesday of next week. Compute the mu and sigma manually with detailed solutions. Write your answer in yellow papers, not back to back. Use only the front page. Do not forget to write your complete name, your complete schedule, and the answer with the corresponding detailed solution. So CB is equal to sigma divided by mu times 100%. So 3.3 divided by 72.8 times 100%. So approximately 4.5%. So what's the meaning? So the mean height is approximately 187, 187.8 pounds. So the standard deviation of sigma is equal to 17.7 pounds. The coefficient of variation for the weights is, so we have here CB, sigma divided by mu times 100, 17.7 divided by 187.8 times 100%. So approximately 9.4%. So the weights, 9.4%, are more variable than the heights, 4.5. So the greater the value of the CB, that means greater variability. And the smaller the value of CB, that means smaller variability. If there's a greater variability, that means the values are far to each other or more heterogeneous. If there is a lesser variability, meaning the values are close to each other, or the values of the data are somewhat homogeneous. So take note on the computation of CD. So the first assignment is this one, your computation of mu and computation of sigma. Second assignment is the computation of mu na approximately 187.8 and the sigma approximately 17.7. So the data given would be this heights data and then the weights data. So with this kind of data, you are going to have assignment number 1 and assignment number 2. So take note of that assignment. And then the other assignment that you are going to do is about this. So if you look at this kind of data in here, I would like you to calculate the mean. We're going to have the sample mean. Consider this one. Starting salaries for Corporation B in thousands of dollars. Look at only Corporation B. We have the salary 40, 23, 41, 50, 49, 32, 41, 29, 52, 58. Consider this data are sample data, and then calculate the sample mean, then the sample standard deviation. Sample mean, sample standard deviation, and then together with the sample variance. So the same too, that would be assignment number 3. And looking back to assignment number 1 and assignment number 2, after calculating the population standard deviation, I would like you to calculate also the population variance. So from this given here, we calculate already in manual perspective the sample or the population standard deviation. So calculate the population variance for both number 1 and number 2. So don't forget there are 3 assignments after watching this video. Assignment number 1, assignment number 2, and assignment number 3. And all of those will be in yellow papers, not back to back. Make use only of the front page, and that you're going to have the complete name, complete time schedule, and then the assignment. Thank you very much.